The crust is further divided into upper crust, continental crust composed of silica and aluminum, Cl, and the lower crust, oceanic crust made up of silica and magnesium, sigma. The boundary between the upper crust and the lower crust is termed as conoroid boundary. The thickness of the crust varies from oceans to continental oceans. Oceanic crust is thinner when compared to the continental crust. The mean thickness of oceanic crust is 5 km. Continental crust is around 30 km. The continental crust is thicker in the areas of major mountain systems. It is as much as 70 km thick in the Himalayan region. The density of the crust is less than 2.7 gram per centimeter cube. The mantle is composed of silica, magnesium, and iron. It lies between the lower crust and the outer core. It extends for about 2,900 kilometers, divided into the upper mantle and the lower mantle. The mantle generally is in a solid state. The upper part of the mantle is called asthenosphere. The word "asthen" in Greek means weak. It extends up to 400 kilometers and the main source of magma. Mohorovicic is the boundary which divides the lower crust and the upper mantle. The core forms the center of the Earth. Its density is about 13 gram per centimeter cube. Its temperature is about 5,500 degrees Celsius to 6,000 degrees Celsius. The core has two parts, namely the outer core and the inner core. The boundary between the lower mantle and the outer core is called Gutenberg margin. The outer core and the inner core are separated by Lehmannboundary. The outer core is in the liquid state while the inner core is in the solid state. Generally, the core is composed of nickel and ferrous iron, which is called NiFe. Where the core is extended from 2,900 km to 6,370 km from the surface of the Earth. Continental drift theory was proposed by Alfred Wegener in 1912 that all the continents once were together form a single continent. According to him, about 250 million years ago, the Earth was made up of single landmass called Pangaea, and a single ocean surrounding it is called Panthalassa. Over a long period of time, probably 220 million years ago, they drifted apart and gradually moved to form the present position. First Pangaea, namely into two landmasses, namely Laurasia in the north and Gondwana in the south. These three found within Laurasia and Gondwana. Laurasia further split into Eurasia and North America. Gondwana's land split into Africa, South America, Antarctica, Australia, and India. A continental drift theory is found by the following evidences that in identical rare fossils have been found in different continents of fossils of Mesosaurus, a small Permian reptile, for example, having found only in Africa and South America. The fossil of a fern trace of about 30 million year old has been found only in India and Antarctica. Rocks of similar type formation age have been found in African basin. Geological structure in Newfoundland matches with that of the Ireland, Scotland, and Scandinavia. Geological structure of Appalachian Mountains matches with Morocco and Algeria and North Africa. The corresponding edges of the continents fit together. For example, the western side of Africa and the eastern side of South America fit together. Plate boundaries are the zones where the two or more plates move about. Plate tectonics describes the distribution and motion of the plate's surface is composed of rigid lithospheric slabs, technically called plates. The word tectonic is derived from the Greek word tekton, means builders. Lithospheric plates are sometimes called as crustal plates or tectonic plates. Earth's lithosphere is divided into a series of major and minor mobile plates: Eurasian plate, Indo-Australian plate, North American plate, South American plate, Pacific plate, African plate, and Arabian plate. Caribbean plate, Caucasus plate, and Scotia plate are the examples of minor plates. They move at the rate of 2 to 3 centimeters per year. Plates are composed of the continental or oceanic landmass. The subduction of the oceanic plates result in the occurrence of earthquakes and volcanoes adjacent to the trenches. Plate margins mark the occurrence of most significant landforms, including volcanoes, fold mountains, island arcs, and deep sea trenches. There are three principal types of plate boundaries. They are divergent, convergent, and transform boundaries. Divergent boundaries, the margin where two plates move apart. For instance, the African plate and the South American plate move apart and form a divergent plate boundary. Narrow oceans represent young divergent boundaries, and wide oceans are indications of old ocean basins. Ocean ridges are the boundaries between plates of the lithosphere. A fissure is created when oceanic lithosphere separates along the oceanic plate boundary. The gap is filled by magma that rises from the asthenosphere. The magma cools and solidifies to create a new oceanic crust. Hence, the divergent plate boundary is termed as the constructive plate boundary. It is also called as accreting plate margin. Firstly, submarine mountain ridges formed through the rich fissures in the oceanic crust when the plates move up. The mid-Atlantic ridge is an ideal example of a submarine mountain ridge in the Atlantic Ocean. It is the longest mountain ridge in the world. It extends for about 16,000 km in a S-shaped path between Iceland in the north and Bouvet Island in the south. It is about 80 to 120 km wide. It reaches above sea level in some places, thus forming the islands such as the Azores, Ascension, Saint Helena, and Tristan da Cunha. Secondly, rift valleys formed when two plates move apart. If a divergent boundary runs through the continent, the continent splits apart and rift valleys formed. The African Rift Valley of East Africa is an example. Convergent plate boundary is the margin where two plates collide with one another. South American plate and Nazca plate collide with each other. There are two kinds of surface features associated with the convergent margin. The first is the ocean trench that forms a line between the two colliding plates. A trench is a narrow and deep depression of the ocean floor. It is formed when the oceanic plates slide down underneath the continental plate, as the oceanic plate is denser than the continental plate. For instance, Mariana Trench in the Pacific Ocean is the densest trench in the world. It is formed by when the Pacific layer sinks down the Eurasian plate. It is about 10,994 meters deep. Mariana Trench stretches for more than 2,540 kilometers with a width of 69 kilometers. You could take Mount Everest and sink it in the Mariana Trench, the deepest point in the ocean, and still you have a kilometer of depth to reach the surface of the ocean. When a continental plate and an oceanic plate collide with each other, denser oceanic plate sinks below the lighter continental plate. Subduction zone is formed. A subduction zone is a boundary where one plate sinks under other plate, which was first identified by Keo, Adati, and Benioff. Secondly, fold mountain is formed when two plates collide with each other. For example, Himalayas that formed when the Indian plate collided with the Eurasian plate. The zone marking the boundary of the two colliding plates is known as the switcher line. As the crust is less dense than the mantle, the newly formed magma will tend to rise to the earth's surface, where it may form volcanoes. The area in the subduction zone where most earthquakes occur is known as Benioff zone. Transform plate boundaries, the margin where two plates move side by side. The lithosphere is neither destroyed nor created by the transform plate boundary. Hence, it is called as conservative or passive plate boundary. The San Andreas Fault, California, is a transform boundary that separates the North American plate and Pacific plates. When the molten materials circulate in different directions, they push or pull the plates in different directions. As the plate moves towards each other, move away from one another, move side by side. The plate movements cause the formation of fold, fault, earthquake, and volcano to occur. Horizontal movements are produced by forces of compression and tension. Folding is the bending of rock strata due to compression. Folding on a large scale results in mountain building, generally referred to as orogeny. Up-thrown part of a fold is called anticline. Down-thrown part of a fold is called syncline. The side of the fold is a limb. The top of the fold is the crest. The plane in which bisects the angle between the two limbs is called the axis of fold or axial plane. The fold is formed by the plate movements. The types of fold are when compression fold force is equal from both sides. The angle of the limb is same on both sides. Such a fold is called symmetrical fold. When the compression force is more from one end and one limb is steeper than the other, such a fold is called asymmetrical fold. When the isosceles folds are similar to symmetrical folds, but these folds both have same angle and are parallel to each other. Iso means the same, symmetrical and cline means angle. So this literally means the same angle. So isoclinal folds are symmetrical and aligned in a parallel fashion. When one limb of the fold is pushed over the other limb of the fold, it is called as overturned fold. Limbs are seldom horizontal. When one side of the fold is pushed so that it lies positioned over the other, a fold is called a recumbent fold. When plates converge, the weak rocks and sediments lying between two plates get squeezed and folded. Parallel folds form long chains of mountain ranges with high peaks. The fold mountains are characterized by peaks and valleys. The tops of anticlines become the peaks and synclines become the valleys. Intermountain plateaus surrounded by the mountain ranges. All sites may be found between the high ranges. Example, Tibet. A fault is a break in the Earth's crust where blocks of rock crust slide past each other. Usually, it occurs along the plate boundaries where the forces of plate motion compresses, pull, or shear the crust or that breaks the crust.